Hi everyone, welcome back to our series of discussion in statics of rigid bodies. Our topic in this presentation is all about the other application of cross product. And this time, we will consider how cross product are used in the determination of the distance between two non-intersecting vectors. So guys, patuloy nating subaybayan itong ating series na ito sa pamamagitan ng pag-subscribe at pag-click ng notification buttons so that you will be always notified of our next uploads. So our topic for today is the application of cross product. We know that cross product can be used to determine the distance between two non-intersecting vectors. Let us imagine that we have here our three mutually perpendicular axes, the x, the y, and the z axis, such that this point is our origin and this is the direction of our x-axis. Here is the direction of our y-axis and this is the direction of our z-axis. This plane represents the xy plane, while this plane represents the xz plane, and this plane represents the yz plane. And let us imagine that on this space, there are points. Namely, we have point A whose coordinate is at x sub A, y sub A, z sub A. Somewhere here, we also have another point B whose coordinate is at x sub B, y sub B, and z sub B. And on these points, there is a vector that is directed towards from A towards B. Let us imagine that there is another point C whose coordinate is x sub C, y sub C, and z sub C. And somewhere here is another point E whose coordinate is x sub E, y sub E, and z sub E. And from C, there is a vector that runs towards E. Let us recall the concept that the shortest distance between a point to a line is the line drawn from that point perpendicular to the line. Alam naman natin na ang shortest distance daw ay siyang distance na nagraran from a point towards the line which is perpendicular to it. And from that concept, this leads to another concept that the shortest distance between two non-intersecting vectors is the line or is the length of the line that is perpendicular to both of the two non-intersecting vectors. And we will call that as the length of the common perpendicular. Kaya kung meron tayong line that will be perpendicular to vector AB in this direction and also perpendicular to vector CA, then this line will be the shortest distance and the distance between the two non-intersecting vectors. Now, how are we going to determine its magnitude? The magnitude of that shortest distance or length of the common perpendicular is the projection along the direction of the common perpendicular of any vector that will connect the two non-intersecting vectors. So how are we going to interpret that? Ang sabi dito, yung daw magnitude ng common perpendicular ay siyang projection ng anumang vector that will connect the two non-intersecting vectors, along the direction of that common perpendicular. And so, which common perpendicular are we going to consider here? So to show that, let us consider 2 points on the figure. Along AB, we select point A, while along CE, we consider point E. And so, the line that will join E towards A is a vector that we consider a connecting vector. A vector that will connect the two vectors CE and AB. But it's not limited to that vector. We can also select this vector CA. We can also select this vector CB. Or we can even select this vector C. All these vectors all these vectors are the vectors that are considered to be connecting the two non-intersecting vectors. And so, how are we going to determine the magnitude of that common perpendicular? So let us now try to imagine that we view the figure from the tail of the vector CE. Let us imagine that we will be viewing this figure as if we are somewhere here, viewing it from the tail of the vector CE. So that, imagine that you are here and you are viewing the figure in this direction. So the question is, how are you going to see the illustration? And in particular, okay, I would like you to consider what will you see, how are you going to see the vector CE and the vector AB. Now let us try to imagine it this way. If you will be looking it this way, you will notice that you will see vector point C and E at a common point because you are standing or viewing it from the tail of KCE. And you will see AB somewhat inclined in this direction, and the distance D shall be the one perpendicular to the vector AB and will pass through the vector EC. And that is what we will see when you will be viewing it from this point. Now, what is the vector EA that we have just shown a while ago? The vector EA is this vector that will connect E and A. This is our REA, or we will be calling it as the position vector of point A referred from A. And this would have a magnitude equal to REAM. Now, let us try to recall back our concept that we have studied a while ago, last time. So from the previous discussion, we learned that the length of the distance D, the length of this distance, is the projection of the magnitude of REAM along the direction of this KD. And that is actually the application of the dot product such that that distance D becomes the dot product of REA, K dot, and D, where in this particular example or formula, REA is the cross product, the vector that connects the two non-intersecting vector. And ND is the direction of the common perpendicular, which is the ratio of the cross product of the vectors along AB and along CE, which is divided by the magnitude. So in symbol, we write that ND as being also equal to N sub C, which is the ratio of C over C sub M. Now, what is this? A direction. The direction can be specified by as the direction of the cross product of the two non-intersecting vector. If you are going to see that figure, here is the direction of that D. This is the direction of the T, and at the same time, the direction of the cross product of the two non-intersecting vectors. And this C is the cross product of RAB, okay, and RCE, which are the two non-intersecting vectors. RAB is the vector that is directed from A towards B, and RCE is the vector that is directed from C towards E. And we can use actually that as the position vector. So to easily follow and to understand the application of that cross product, let us try to have this particular example. Okay, in the problem, we are required to find for the shortest distance between the line FG and the line CD as shown in the figure. So here is the figure. So the figure looks like a post that is supported by different cables that are directed or connected from different points. One cable is a cable joins point F and G. The other one is the cable that connects A and B, A and E, and the other one is the cable that connects C and D. So the dimensions of the cables are indicated in the figure. And from here, we wanted to determine the magnitude of the distance between the line FG, this line, and the line CD, this line. So when we say the distance, we are talking of the shortest distance. So how are we going to solve for the shortest distance? So we can solve for that using the application of the cross product. And we will start that with identifying the coordinates of the points involved in the problem. Those are the points F, G, C, and D. Now, what are the coordinates of points? Let's do it one by one. The coordinate of point A, F will be shown here to be equal to -1, 0, and 2 because it is directed towards the negative x-axis, lying along the xy plane, and directed towards the positive z-axis at the magnitude of 2. And so the coordinate will be at -1, 0, and 2. Similarly, we have here, okay, the coordinate of point G, which is at -1, 3, and 0. And so we write it here. The coordinate of point C at 0, 4.5, and -1.5. And so we write it here. And so the coordinate of point D at 4, 0, and 0. So from this coordinate, we can now identify the vector, okay, the two non-intersecting vectors, such as this one. This is the first vector that is identified, okay, as the vector that is passing through F and G, which are whose coordinates are given in this, okay, shaded value coordinates. The vector FG shall be the difference in the coordinates of the x and y, g and f components. Coordinates. That is -1 minus -1 coming from these two of I, plus 3 minus 0 of j, plus 0 minus 2 of k. So that when we simplify that, that is equal to 0i plus 3j minus 2k. The other vector can be shown by this symbol, by this arrow, and that is the vector FC, and whose coordinates are given by this rectangle. So that the position vector RCD can now be expressed as the difference between 4 and 0, 0 and -4.5, and then 0 and -5. And so that is 4 minus 0i plus 0 minus 4.5j plus 0 minus -1.5k. And so when we simplify, that becomes equal to 4i minus 4.5j plus 1.5k. And what about those vectors that will connect the two non-intersecting vectors? If you are going to look at the figure, there are several vectors that we can use to connect the two non-intersecting vector. One of them is this vector that runs from F to D. This vector that runs from F to D. How are we going to get this vector? These points have these coordinates. You see this one. And so the vector could be RFD equal to 4 minus -1 plus 0 minus 0 of j, plus 0 minus 2 of k. And so when we simplify, that is equal to 5i plus 0j minus 2k. We can also take this vector as another vector that will connect FG and CD, so that this vector have the following coordinates. Okay, so that when we solve for the position vector of C and G, then that becomes RGC equal to 0 minus -1 I plus 4.5 minus 3 k plus 5 minus 0, so that when we simplify, that becomes equal to 1i k plus 1.5j minus 1.5k. And we can also use this vector whose coordinate shall have this as shown in the figure, so that when we solve for the position vector of that vector, then we shall have 0 minus -1, this one 0 minus -1 plus 4.5 minus 0 plus -1.5 minus 2. And so when we simplify, that becomes RFC equal to 1i plus 4.5j minus 3.5k. Or we can also have this one, so that we have this as our coordinate, and when we solve for f sub g, we have 4 minus -1i plus 0 minus 3j plus 0 minus 0k. And so we have 5i minus tj plus 0k. So all of this, or any one of these, a vector that joins the two non-intersecting vectors can be used so that when this will be projected along the direction of the cross product of the two non-intersecting vectors, then we will be getting the distance between the two non-intersecting vectors. So what shall we do next? So we try to solve for the cross product of the two non-intersecting vectors, and we call it C, so that C shall be equal to the cross product of FG and that of CD. And when we substitute the value of the position of vector FG, so we have this vector as well as that of CD, then this is equal to that of the magnitude. And so when we apply the third order determinant, so we solve for C, so what shall we do? C shall be equal to the determinants of the first row of the determinant is actually the first element of the cross product. The second row of the determinant is the second element of the cross product, while the third row is the I, J, K, or the directions of the positive X, Y, and Z axis. So what we do is to extend the first two columns. So 0, 4, and I is written here, and 3, negative 4, and J is also extended in that direction. So that when we solve for I, so we can solve for I using this computation. The arrows downward shall be equal to positive, and hence you have 4.5. While this one we have a negative 9. And for J, we shall have this value that becomes negative 8, while this one shall be equal to 0. So that for K, we shall have this as 0 and this at negative 12. So when we simplify that, then this becomes KC equal to a negative 4.5i, a minus 8j, minus 12k. This becomes now the cross product of the two non-intersecting vectors expressed in terms of vector notation. So we need to solve for the direction, and therefore the direction is the ratio of the cross product divided by the magnitude of the cross product. And so we say that that is the ratio of the C over C sub M. So what we do is just substitute the C here, and we solve for the magnitude as the square root of negative 4.5 square plus negative 8 square plus negative 12 square. And when we simplify, then this becomes equal to negative 4.5i minus 8j minus 12k divided by the square root of 228.25. Now after solving for the direction of that cross product, then this cross product shall be the direction from which any of these connecting vectors may be projected, and the projected of these vectors along this direction shall be the magnitude of the distance between the two non-intersecting vectors. And so we continue with the solution. We try to solve for the distance, so that the distance is the projection. When you say projection, that becomes the that product of the connecting vectors, that of the direction of n sub c. So we can we try to select this one as the first connecting vector. So when we substitute it there, so we have negative 5i plus 0j minus 2k. That the direction of this direction. So when we substituted it there, so we have negative 4i minus 8j minus 12k divided by the square root of 228.25. And so we now simplify it using the dot product. 5 multiplied by negative 4.5 gives us a negative value of 22.5. 0 times negative 8 gives us 0, and negative 2 times negative 12 gives us a positive 24. Dividing it by the magnitude of C sub m at 228.25. Now when this will be simplified, how much will this be? That becomes equal to 1.5 over the square root of 228.25. And that gives us a value actually of 0.09928. Now would that be the same if we consider the other connecting vector? Say for example, we wanted to take this connecting vector and this one. say for we wanted to take another connecting vector and we wanted to take this a second connecting vector. So what we do is to substitute that in the formula, that the distance becomes 1i plus 1.5j minus 1.5k multiplied by again the direction of the cross product. And so when we simplify, that gives us 1 multiplied by negative 0.5 is negative 0.5, 1.5 multiplied by 8 is negative 12, and then 1.5 negative 1.5 multiplied by negative 12 is positive 18. And then when we simplify this, okay, that will also give us a value of 1.5 divided by 228.2, square root of 228.25. And so the value of the distance will also give us the same value at 0.09928. And so you are able to see the process of using the cross product in defining or in determining the distance between two non-intersecting vectors. Kaya guys, sana ay nasundan niyo yung ating ginawang discussion, and if you are not yet subscribed, I am inviting you to subscribe to my channel so that my next upload you will be notified. Again, thank you again for watching.